Alright, so this is lesson 7, solving multi-step equations. To solve any multi-step equation, we use the properties of equality, inverse operations, and the properties of real numbers. The properties of inverse operations are the multiplicative inverse and the, additive inverse. And then we also have the properties of equality, which is that associative, distributive, and commutative properties. I also put up here to combine like terms and the order of operations backwards, because that's how we undo any of the equations as we're trying to solve for a specific variable. Alright, so let's solve one of these multi-step equations. We have the equation 5 equals 5m minus 23 plus 2m. And that's the given. That's what's given to us in this question. So now we're going to start manipulating this equation using our properties so that we can eventually isolate the variable m by itself and find out what m equals. In order to do that, first thing we're going to do is I see that we have this 2m and this 5m here. These are like terms. So I'm going to try to put those two terms together as best I can. I can do that using the commutative property by moving this 2m and this negative 23. So let me do that. So I moved the negative 23 and the 2m. Remember, I can do that because this negative 23 is the same thing as saying plus a negative 23 plus a negative 23. So now I can move it because I have the additive property of, the commutative property of addition. Next thing we're going to do is combine those like terms. So I have 5m plus 2m, and that's going to equal 7m. So 5 equals 7m minus 23. Now again, I want to try to get this m by itself. In order to do that, I have to first I have to do the order of operations backwards. So notice I have this subtraction here, this minus 23. So that's the last thing in the PEMDAS order of operations. So it's the first thing I need to do to start undoing this equation and unraveling it. So I'm going to use the additive inverse. So the additive inverse of negative 23 is a positive 23. So I want to add 23 to both sides. Now, why do I have to do it to both sides? Because again, in equations like a scale, it has to stay balanced. If I do something to one side, I must do it to the other side as well. So here we see that now I've applied the additive inverse. Now let's simplify that. So the minus 23 plus 23, that's going to become 0, which is perfect because that's what an additive inverse is supposed to do. And 5 plus 23 is 28. So I'm left with 28 equals 7m. Now to undo this multiplication, this 7m here, I need to use what we call the multiplicative inverse. And again, the multiplicative inverse is very much, it's using a reciprocal. So right there I have 7, which is really 7 over 1. Any whole number is just as a fraction, it's over 1. So the reciprocal of 7 over 1 would be 1 over 7. So 1 over 7 times 7 over 1, that gives me 7 over 7. And I have 28 times 1 over 7. Let me show that in the step above here. So I did 1 over 7 times 28. So again, you multiply straight across, so 28 over 7 is what I'm left with. Well, that just means 28 divided by 7, and 28 divided by 7 is 4. And 7 divided by 7 is 1, so I'm left with 4 equals m. And if I want to check that, I can easily just go back and put that 4 back in for m. So 5 equals 5 times 4 minus 23 plus 2 times 4. That says 5 equals 20 minus 23 plus 8. And that says 5 equals 28 minus 23. And so 5 equals 5, and it checks. So let's solve another multi-step equation, this time using fractions. You have 3x divided by 4 minus x divided by 3 equals 5. That's our given. The first thing I always like to do is to make sure that we rewrite these fractions so that the variable is kind of on the side instead of in the top. It makes it a little easier to notice that that's actually 3/4 times x and 1/3 times x, because it's going to be important as we start to get common denominators. So that's the next step, is to get the common denominators. The common denominator between fourths and thirds is going to be twelfths. So I can multiply this fraction by 3/3 to get 12 in the bottom, and this fraction by 4/4 to get 12 in the bottom. So 3 times 3 is 9, 3 times 4 is 12, so I have 9/12 x minus 4 times 1 is 4, and 4 times 3 is 12, 12x equals 5. Now the reason I needed common denominators is because whenever you add or subtract fractions, you have to have a common denominator in order to do it. So now we have like terms. We have two fractions that are both have the same denominator, which is 12, and they both have the same variable, which is x. So I just add or subtract the numerators. So 9 minus 4 is 5. I leave the denominator alone. That's twelfths. I still have the variable x, and that equals 5. Now I want to use the multiplicative inverse. So again, we're going to use the reciprocal. So the reciprocal of 5/12 is 12/5. So let's multiply both sides by 12/5. And the goal here is to get 1 on the side of the variable. So multiply times 12/5. And you see that this becomes 12 times 5 is 60. 12 times 5 is 60. Anything over itself equals 1. And on this side, I have 5 times 12 is 60, and divided by 5. 60 divided by 60 is 1, so that leaves me with 1x. And 60 divided by 5 here is 12. So x equals 12 when we simplify. Let's put all of this into practice now with this word problem. Julie takes her sister and brother to a concert. She buys stickers and shirts for them. Each sticker costs $1. Julie's sister wants 4 of those stickers and 1 shirt, and her brother only wants 2 shirts. So if the total sale is $67, what is the cost of 1 shirt? Okay, so whenever we're looking at a word problem like this, we have to come up with some sort of strategy. I think here I'm looking at the cost of the sister's items and the cost of the brother's items and the total cost. Well, the total cost is easy. That's right here. That's $67. And the cost of her sister's items, well, she wanted, let's see, Julie's sister wants 4 stickers and 1 shirt. So she wants 4 stickers and 1 shirt. And the brother wants, he only wants 2 shirts. So I'm going to write 2 shirts. Now, when I add that together, the 4 stickers and 1 shirt plus the 2 shirts, that should equal $67. So I'm starting to create an equation for myself. What is it I'm missing? Well, I know that the stickers cost $1. And the question actually, if you always go to the end of these word problems, it almost always tells you what it is you're supposed to be looking for. I'm looking for the cost of a shirt. So that's what I don't know, is the cost of a shirt. So we're going to let S equal the cost of 1 shirt. Now I can define, I know exactly what I'm looking for. I'm looking for the cost of a shirt, and I can start to try and create an equation using all this information. So if the stickers are $1 a piece and the sister wants 4 of them, well, that's going to be $4. And she wants 1 shirt. Well, a shirt is going to be defined as just S. So 4 plus S. That is all of the sister stuff. Now let's work on the brother. The brother, well, I know this is going to get added together. I'll put parentheses on that for the sister. The brother wants 2 shirts, so we're going to have 2 shirts. That's the brother's. And then that equals the total cost of $67. So I don't really need these parentheses here anymore. I can just rewrite it. 4 plus S plus 2S equals 67. S plus 2S combining like terms is going to tell me 4 plus 3S equals 67. I'm going to use the additive inverse. I have a positive 4 here, so I'm going to subtract 4 from both sides. Minus 4, minus 4. So a positive 4 and a negative 4 is 0, leaving me with just the 3s. And 67 minus 4 is 63. Now I'm going to use the multiplicative inverse of 3. So 3 is really 3 over 1. So multiplicative inverse here is 1 over 3. It's the reciprocal. It's the same thing as just dividing by 3. Multiply by 1 over 3. So the multiplicative inverse results in 1 all the time. So that just leaves me with 1s over here. And this leaves me with 63 divided by 3, which is 21. So the cost of a shirt is $21. So what I'd like for you to bring to class next time is I'd like you to take this work section on this slide, and I'd like you to write the reason for each step along the way. Any of the properties that we talked about at the very beginning of this lesson. I think there were 7 of them. Look back at the previous 2 slides if you need any help. Good luck, and bring that in for me tomorrow. See you.